Hello everyone. Today's lesson is on proportional and non-proportional relationships. So let's first define what a proportional relationship is. And in fact, our lessons, we're going to have a couple different lessons on this. This is just the first one, determining proportionality from charts, basically, is what we're doing. So to be proportional, means from the book there's a constant ratio or unit rate. Okay, so unit rate we know how to calculate. What this means in Mrs. Sanford world is there is all the fractions that we make out of our charts. And put all fractions reduce down to the same fraction. Okay? Or if you're being really lazy, you can change them all to decimals and they should all go down to the same decimal. But what we're doing here, if they reduce all down to the same fraction, this is called equivalent ratios. That's supposed to be an S. Equivalent ratios or equivalent fractions. Right, because ratios is just a fancy word for fractions at this point in the game. Okay, so to determine, sorry, my cat is mad. I don't know if you can hear her, but she is meowing. And yes, I'm making this video from home, and that's okay. To determine proportionality, which is a fancy word, proportionality. We'll put the terms, put the terms into fractions, and they're pretty much fractions. They're pretty much already there for you in the way that we'll write the charts. And then reduce. Okay, if they reduce to the same fraction, that means they're proportional. Yay. If not, they don't. And I'll give you another key trick to telling whether, without even having to do calculations, how to determine whether or not it's going to be proportional. Okay, so first situation, you are mowing lawns and you get $18 an hour. So, and then we want to know if that is a proportional relationship. So the money earned, we're going to put there, and time we'll put underneath, and we'll make a little chart. And so you've earned $18 for 1 hour of work. And then for 2 hours of work, you get $36. And for 3 hours of work, you get $54. And for 4 hours of work, you get $72. Okay? So we can look at each one of these as a fraction and reduce them down. If we divide the top and the bottom here by 2, do we get 18 over 1? And we do. If we divide the top and the bottom here by 3, do we get 18 over 1? We do. So on and so forth. Another way to determine it is you can actually subtract or find the difference between each of the numbers. The difference between 1 and 2 is 1. The difference between 2 and 3 is 1. The difference between 3 and 4 is 1. If we do that up top, the difference between 36 and 18 is 18. The difference between 36 and 54 is 18. the difference between 54 and 72 is 18. And we can write these changes as our constant rate or ratio, which is that $18 per hour. So yes, this is proportional. Okay. Another situation. Okay, we are buying tickets to a baseball game, and the ticket website charges $7 per ticket. Okay, and then for each order, there is a $3 processing fee. I should put the 3 in there. $3 processing fee. Okay, so if we put together our table, the cost and the number of tickets. Okay, so for one ticket, it's the $7 plus the $3 processing fee, which is $10. For two tickets, that's 2 times 7, which is 14, plus the $3 processing fee is 17. 3 tickets, that's 21, plus 3 is 24. And 4 tickets, that's 28, plus 3 is 31. Okay? So we do have a constant rate of change, because as we go up 1 here, we're going up 7 here. However, if we look at reducing the fractions, 10 over 1 reduces to 10. 17 over 2, 17 over 2 does not reduce down to 10 over 1. 17 over 2 doesn't reduce, really, because 17's not even. 24 over 3 reduces to 8. So this reduces to 10. 17 over 2, if we do the division, is 8.5. 24 divided by 3 is 8. 31 divided by 4 is 7.75. Are these equivalent? And I say to you, they are not. Therefore, this is not proportional. Okay? And the key on this one, or really on any one of these, is if there is an extra something, extra money or whatever added in. Oh, I can do this. A little extra something added in, or started with extra in the beginning, start not at 0. Those are clues that it's probably not going to be proportional. But I would like you to do the math anyway. Okay? Now, this is a tricky one. We're going to talk about proportionality of area versus perimeter. So let's have, I'm going to make a little rectangle here, and this side is going to be x, and this side is 2x. It's twice as long as that side. Okay, and first we want to know, is side to perimeter proportional? And then the next one we want to know is side to area proportional. So let's just remember some geometry really quick. Perimeter is adding up all the sides. Area is one side times the other side. So let's put together a little chart. So we'll put side on the bottom and perimeter on the top. And we're just going to pick some numbers to put in for the sides. So if we pick 1 to be the smaller side, then the perimeter is going to be 1 times 2, which is 2. Okay, if we have 2 is our side, then our perimeter, 2 times 2, is 4. Actually, no, just kidding. I'm just calculating the that side. Woo! And this is why we do math in pencil. Okay, so perimeter, if this side is 1, this side is 2. If we add them all up, that would mean we'd have 1 plus 2 plus 1 plus 2. So that's 3, and that's 3. So altogether, that's 6. Whew, that's better. If the sides are 2, that means these two sides are 2, and these two sides are 4. Okay? So 4 plus 4 is 8 plus 2 is 10 plus another 2 is 12. Is that looking proportional so far? If this side is 3, then this side is 6. 3 and 6. 6 plus 6 is 12, plus another 6 is 18. Okay? And just looking at them right now, 6, if we do this division, it's 6. If we do this division, it's 6. Okay, so I think this one is proportional. Okay, let's do the same thing, but calculating the area this time. So we're going to have the side and area, and I won't mess it up quite so bad this time. So if we have 1 as our sides, then that would be 1 times 2, which is 2. If 2 is our side, so that means we have 2 and 4, and that was 2 times 4 is 8. If 3 is our side, so that's 3 and 6, 3 times 6 is 18. Do these reduce down to the same thing? This one reduces down to 2, this one reduces down to 4, this one reduces down to 6. Are those the same number? Nope. So this is not proportional. Is there a pattern to it? Absolutely. But it's not proportional. Okay. And the last example is you start with a bank account of $120, and then you plan on depositing $20 per week. Now, without doing the math, I'm just going to say, because we start out not at 0, that this is not going to end up being proportional. However, let's do the math to verify and make sure. So we're going to have weeks on the bottom and how much money on the top. Make ourselves a little chart. So in the first week, we're going to have, we already had the 120, and then we're going to add 20 to it, so that's 140. Okay, the second week, we're going to add $20 to that, so that's 160. Third week, add $20 to that is 180. And fourth week, add $20 to that is 200. Okay, so 140 reduces down to 140. 160 reduces down to 80. 180 reduces down to 60. And 200 divided by 4 is 50. Are these the same amount? They are not. Therefore, this is not proportional. Okay? So that's the basic idea from charts of being proportional or non-proportional.